Hello friends, so today we're going to discuss another problem from the latest educational Codeforces round 103, problem B, inflation. So in this problem statement, you are actually given n positive numbers. As you can see, the pth number, the p0th number is actually the initial price of the product, and the pi is like pi shows how the price was increased during the ith month. So as you can see, this is the initial price. Now the like for the price of the next month, it is equal to this plus 1. The price of this is this plus 202. It's actually increasing by this number. So the first defines the actual price of that value, then the product, and this is actually how much the price incremented in every month. Now you actually have to calculate the inflation coefficient. The inflation coefficient is actually equal to the value of the next month. So as you can see, the increment in the next month divided by the total summation till that point, previously till that point. Which I mean by this is, if you understand more with the example, let's just assume that this is the array, okay, in which this is the initial, this is the initial product price, and these are the increments in each month. So for this, for this month, the increment or the inflation coefficient is equal to this value divided by the total summation previous to this. Total summation previous to this is this. Okay, the inflation coefficient for this month is equal to this value divided by the total total summation till this value, like previous to this, which is like this. So the total previous is equal to the original plus the increments. So this is the increment. As you can see, the total is 106 plus 50. So the total inflation coefficient for this month is this value divided by the total increments, which is like summation of this value. So I hope you understand what is inflation coefficient now. Now you want to ensure that the inflation coefficients for all the months should be less than or equal to, it should not exceed k. So it should be less than k%, which means that k% means that k divided by 100. So the coefficients of each month, as you can see, starting from this, it should be less than or equal to k. Okay, if it's incremented by k, if it goes beyond by k, what you actually have to do here is you can increment any value, the price or these increments by any number, such that you have to ensure that the inflation coefficient for any month should not exceed k%. And now you have to find out that what is the minimum total sum of the changes. So as you can see in this example, you have incremented the P0 by 50. As you can see, the initial P0 is this, but you have incremented by 50, and you have also incremented the second value by 49, so it becomes 50, and the rest are same. So now this is the new array, and now for this array, the inflation coefficient for every month is less than or equal to k, which is equal to 1%. Okay, so the total incremented you have done is incremented by 50 in the first value and the 49 by second. The total is summation of this, which is 99. So you have incremented by this in the total array, such that the inflation coefficient for whole the array is less than or equal to k. So I have to ensure that, and now you have to find out the minimum total sum of the changes you have to do. The main trick in this problem is how you can decrement the total coefficient. So in always I always stressed out, in always such type of problem in which you have to divide, try to move the the denominator to the next left hand side or right hand side, so that you don't have to actually divide it out, and the answer do not get in points. So as you can see, the upper value is equal to the value in the array. The array in the value in the denominator is actually the summation, and this is k divided by 100. This value cannot be changed. This value is always a constant. So k divided by 100 is always a constant. But if you divide, so this is a constant, so it is a point value, so you don't actually have to change it. Just you can assume that this is equal to k, a capital K, and this is always constant. But if you take this to this side, so it's this is the a of I. This should be less than equal to the summation. So this is actually sum into k divided by 100. Okay, and now this is actually the previous sum, the sum till the I minus 1 point, and this is the ith point. Okay, so now as you can see, this is a constant, but this is what we can change. Okay, So if we want to somehow satisfy this condition, okay, what we can do, we can obviously, if we increment a of I, we have to increment a of I, we actually have to increment a of I, but if we increment a of I, okay, the previous values, we are doing a summation of the previous values, this is the sum of previous values, okay. If we somehow make this value increment, if this value is enlarged, like this value is incremented, then obviously this a of I, like this total will increment, because this value is incremented, so the total will increment, and thus this can become greater than or equal to a of I. We want to just satisfy that. So what I mean by this is, if you want to increment this value, this is actually the sum of all the values behind this current element. And as you can see, the first element is always behind every element. So why not just increment the first element by some value, okay, and then check that whether the whole array is satisfied, okay. And that's the whole crux of this problem. You only have to increment in the first initial value, okay, and then you have to check that after incrementing in the first position only, can I make the whole array, like the coefficient, inflation coefficient, less than or equal to k. So now like how much do you want to increment? Okay, so now as you can see, in O of n, I can check that whether the whole array, because as you can see, to check the whole array whether it is satisfying or not, what you actually have to do, just take the current element divided by the total summation previous to it. So you can just easily find out this in O of n. So now you actually have to just find out how much increment you have to do, and now you can just find out the increment in binary search operation, because in log of n you just take out any value, because this is, as you can see, what you can say, when we only apply binary search when it is a monotonic function. And as you can see, after a certain point, if you increment more, so let's assume that I increment the whole, like the initial value, by a very large number, then obviously the total summation will obviously increment a very large number, and this value will become very large. And if it becomes very large, this total value will become very large, and thus this obviously it obviously become greater than a of I in all the cases, because a of I is all of these values. We are not changing them, these are constant, but we are only incrementing the first value. And if I increment the first value, these always remain the same, but this becomes very large. So as you can see, for the further cases, even if I incremented more largely, my cases will always turns out to be true. The answer will always turns out to be true, because at that case also the percent of k will become greater than or equal to the value which you want. Thus we just have to find out the minimum possible value, and that's what we have. Like in this problem, you can also see that we can make the bigger changes, we can also make bigger changes, and then you can obviously see that we have made more cheating. We can make this starting value a very large number, and if you make a very large number, then the reviewer can assume that obviously that there is some mistake, you have done some changes. So you want to make the sum least as possible, and thus you can understand that this is some sort of binary search problem. And thus what you actually have to do here is, you just have to increment the first value by some middle value, and just check that whether like this value is satisfying the whole condition and making my whole array, the inflation coefficient at each position, less than or equal to k. If it is satisfying, then obviously this point is correct. We actually have to do a binary search on the, like if the middle is correct and like this is correct, then we have to go to the left side, else if it is not correct, we have to go to the right side, and that's it. I'll take it on to the code part now to even make it more clear. So this is the input of n and k, make everything in long, okay. Then this is the total summation, we actually don't require it. Then take the input of all the elements. So this is from a very large number, from 0 till a very large number, 10 to the power 14. Okay, you can also make 10 to the power 15, whatever you want. Just don't make it 10 to the power 18, because then that number you have to add it to this, because this is a of a plus mid. Okay, and if this middle is actually a very large number, then like an a of a0 is also a very large number. Let's assume that a of 0 is, let's assume like 10 to the power 9. And this is also a very large number, increment of 10 to the power 9, so it can go out of bounds. So don't make it a 10 to the power 9, just make it like, don't make it 10 to the power 18, so make it 10 to the power 15 or 14, whatever you want. Then you just do a binary search, make L less than R, find out the middle element, and increment the first sum plus this middle element. Now this is the OK true function, iterate over from the first to the last element, find out that like this is a sum into k divided by 100. If this value is like, this value should always be greater than or equal to a of I. If it becomes less than a of I, then obviously my this total is false. So I'm making my this OK function, making it to false, variable equal to false, and break it out. Else my new state will be my sum will increment it by a of I to the next position. And if this whole array is satisfied, then OK will turns out to be true. If OK is turned out to be true, then what we have to do, we make our right make equal to mid, else make our left equal to, if it is not satisfied, then this mid value is not satisfied, so make my left equal to mid plus 1. If this is mid is satisfied, then make my right equal to mid, and then the answer is obviously equal to the left part, the left, whatever this left is pointing. Now this is just a standard binary search problem. If you do not understand binary search, or if you want to practice more, I have already made a playlist on binary search. You can watch them out. I can also link that playlist in the description below, or it can be seen in the I button also. You can check that out also. So this is a standard binary search problem, which I have already mentioned in a lot of problems in binary search. So you can check that video out also. I hope you understand the logic as well as the code. Still haven't out, check my channel. As the next one, keep coding. Bye.